What defines the sound of solid body electric guitar the most? Is it the pickup, the hardware, the wood, or the actual construction? Now, more or less, all of these variables play some role. But if you have 4 same guitars with the same specification, they should sound the same, right? But they don't. Hello ladies and gentlemen, my name is Tommy and today we're gonna find out why my 4 ESP Horizons sound differently. Well, I wanted to have 4 guitars with the same specification, but in different tunings, and play one guitar setup with one signal chain, but after some time I found out that it just doesn't work because there are some differences between the guitars and they have to be tamed differently. And it doesn't mean that the guitars are good or bad, it just means that they are different. But I'm curious why, because they should be the same. And today we're gonna find out, hopefully. And one short information, this is not a sponsored video, I paid for all the guitars. And now, let's use some audio samples. Now, you can hear that there are some differences, and the signal from the microphone I just wanted to pick only because you can hear how I feel about the guitar when I play it. But what is mostly important is the actual electrical signal coming out of the guitar. But you can hear that there are some differences too. And I wanted to eliminate any kind of variables here, so I wanted the test to be as bulletproof as possible. And there are a few points I had to take into account. First, the strings. All guitars are tuned into C standard, and I am using for this test Ernie Ball Beefy Slinky 1154s. Second, the pickups. Not only the pickup type is important, so I set up all the pickups to be from 2.5 to 3 mm distance from the lower and higher C string. Third, the impedance measurement. I measured the pickups electrically to be sure that there are no differences between them and that the actual characteristics are the same. Now, there may be some slight variation in the magnetic strength, but the magnetic type is the same, so the tone character shouldn't be affected. Fourth, the acoustic measurement. I recorded all the guitars with the microphone as well, because if we find out that there is some relation between the acoustical signal and the electrical signal, we should focus on the mechanical part of the guitar and not on the electrical. Fifth, the performance. I can't play all the guitars at once, but I try to be as consistent as possible and I used the same pick. Sixth, the tone. Now, I used the same cable directly into my Focusrite Scarlett and the same ML plugin with the same preset, so the only difference you can hear is the guitar. And now it's time to reveal the guitars, so shall we? This is the sample D. This is actually my first guitar. I bought it on the Reverb from one French guy, and this guitar was made in 2011. It arrived in absolutely mint condition. There's no problem about it. I played this guitar so much. The tone from this guitar is just great. I can complain about anything, and yeah, that's it. Moving on. So this is the sample C. This is actually my second guitar I bought from the same French guy. It was made in 2011 and it arrived in, let's say, good condition. It was slightly worse than the first one. The white color is kinda creamy, and especially on the right hand and maybe from the back you can see the Floyd Rose system was kinda rusty, and bridge pickup is the most different of all the guitars right here. So I think that the pickup may have some issue, but let's find out. So this is the sample B. This is actually the last guitar I bought, and you can see that this actually doesn't have the Floyd Rose system. And this is the neck through body construction with no locking nut. And I have to say as well that the neck is kinda angled similarly to Les Pauls. It has the humbucker, not the turnbucker. So the pickup is actually about 3 millimeters shorter. It doesn't have the most bassiest tone at all. On the other hand, the tone is the most, let's say, crystal clear and rocking, and I just fell in love with this guitar for recording rhythm stuff because it just rocks, you know. And this guitar is actually the oldest. It is made in 2010 and I bought it on eBay from Germany, and it arrived in absolutely mint condition. And last but not least, this is the sample A. And this is actually the E2. It is not the ESP anymore, but basically it is the same made in Japan Horizon standard. And this is the only guitar I bought brand new. It's the youngest one. It's made in 2013. And previously there was black hardware and black nut. Now it is changed because of the tests, but I have to say that this is actually the reason why I wanted to do this test for so long, because this guitar should be the most similar to the blue one, but it is the most bassiest guitar from all which I have. So I'm pretty curious what is different, and definitely it is not the mark on the headstock. There should be something else, but it is the same 3-piece maple neck and the same through body construction, so let's find out. Now, I just forgot to mention that these guitars are loaded with Seymour Duncan TB4s, and in case of the brown one, which doesn't have the Floyd Rose, this one is loaded with SH4. But all of the pickups are JBs and 59s. Enough story of these guitars and me, and let's do some science and let's take a look on the impedance measurement. Okay, so now we are in REW software, which is basically for acoustic measurement, for speaker measurement, for speaker EQ, and the most interesting part for us is that here is some impedance measurement.
which is basically designed for measuring a speaker impedance. But in our case, the only difference is the actual amount of impedance, because we are not talking about ones of ohms up to, let's say, hundreds of ohms, but from ones of K up to few hundreds of K. So the only difference is that we are using different value for the sense resistor, and our result is in higher values as well. So I already did all the measurement, and you can see on this diagram that we have 4 curves here, and one is very different and 3 of them are almost identical. So what are these? Basically the red one is for the red guitar, the blue one is for the blue guitar, the black is for the white guitar, because if it would be white you wouldn't see anything and me neither. And the brown one is for the brown guitar with the tune-o-matic bridge. At first sight, what we can see, well, the blue guitar and the red guitar has almost identical pickups. I think this is pretty much in manufacturing tolerance. It is well crafted. The pickups are in electrical standpoint almost the same. You can see only maybe slight difference here in the 8K region, where these may differ a little bit. Let me just turn off these two. So these two pickups are actually almost the same. And what are these kind of spikes here? So these are the products of, let's say, 50 Hz noise in the air, but these are very well suppressed. And what's this and this? I think this is because of some switching mode power supply, and probably this is from the Focusrite Scarlett itself, so maybe there are some ground loops or something like that. So the 8K and 16K is pretty much here, but we can avoid it because this is not about the pickups. Well, when I add the brown guitar, there is a little difference in the, let's say, DC resistance. We don't have the 16.8K, we have something like 16K. But because this is not a humbucker, this is a humbucker, so it is not TB4, it is SH4. It is, let's say, about 3 millimeters shorter. Why is that? Well, the Floyd Rose bridges are wider, and if you want to squeeze the most of the tone from the bridge pickup, you really need to have the poles and the screws right under the strings. So it means that if you have everything the same, but the construction is, let's say, shorter, you got shorter wire you need to produce the same pickup. And in this case, you have a little bit less DC resistance. And there is also very, very subtle difference right here. But let's say these pickups are almost identical, and based on the same construction and the same type of the magnet, they should sound the same. Basically, the most difference should be maybe from the brown guitar, which we can actually hear, but from my opinion, this is because of the construction. It is not the Floyd Rose, it is the tune-o-matic bridge and strings through the body. And why the red guitar has the most output power from all of these? Well, basically I aligned the height of the pickup on all the guitars, and there may be some subtle difference in the magnetic strength. It shouldn't affect the tone itself, because other things like the construction and the material, everything's the same. So I think that the red guitar is the hardest because some differences in the magnet strength. What is very interesting though is the white guitar, because this curve is something absolutely different. Well, why is that? After I measured this curve, I wanted to check if everything's okay, and the neck pickup seems to be absolutely the same like on the other guitars, so it's the problem on the pickup itself. And I checked the DC resistance with a multimeter, which you can see right now. So the actual resistance was measured like 440K. Well, the DC resistance right here is slightly lower, but what is pretty much important is the shape of the curve. We have to remember it because we'll talk about it in few seconds or minutes, but for now, let's say that the white guitar is totally different. There is a problem on the electrical side, and this is the reason why the guitar sounds so much differently in this case. Yeah, so the pickup is the one we should blame, and well, that's all from the measurement standpoint. And now let's talk about some physics.
So what we are gonna talk about? First of all, we'll talk about the electric circuit. Secondly, about the weird impedance curve. And last but not least, we'll talk about the relation between the impedance curve and the actual transfer function, in other words, frequency characteristics of a pickup. So first of all, what do we got here? We got an input impedance of our amplifier or audio device, in our case Focusrite Scarlett. Then we have this impedance model of a cable, which is very important, especially in passive pickup design. And if you are interested about the cable mythology, definitely subscribe and ring the bell, because the next video will be exactly about it. And then we have, let's say, our guitar and the tone control, which is, let's say, as in most Superstrat design, only volume potentiometer with the value around 500K, and the tone control, which is made by this capacitor, and in series the changeable resistor made from the potentiometer. So everything what is in this red dashed box is actually one component, and we cannot divide these components from each other. But basically it is the component made by ideal components, so we can calculate with each parameter separately, and together it behaves as our actual pickup. So what do we got here? First of all, what is a pickup? It is a coil. Well, we have our coil here, and I think the JBs are something around 8 Henry of inductance, something like that. They are as well something like 15 or 16K DC resistance, and this RL circuit is actually the most simplest equivalent circuit for an inductor, but it is made by very thin and very long wires, so this resistance is very important here. And well, we have some voltage source right here. Why? Because we got some source of energy from the outside, which is actually the energy in the strings we put with our hands. And the most important and mostly overlooked component in this equivalent circuit is the capacitor. And this is the reason why we talk about some resonance. And this is the parasitic capacity of our wire inside of this pickup. Well, where does it came from and how it works? You can imagine that, for example, we take the first layer of wires and the last layer of wires. Let's take one surface and another surface in some distance, and basically this is a definition of a capacitor. So the calculation of the turn-to-turn capacity is very complicated, but as a result we can calculate with one capacitor, and it is pretty accurate actually. To the weird impedance curve, I measured with a multimeter value about 440K. Where does it come from? Well, I measured from these points on the left side, so there was no cable, there was no amplifier input, so only what you see from this point to the left side. So what did I measure? If the pickup is disconnected, that's what I thought, we can say that it is disconnected, for example, here. Now, on the DC, the capacitors are, let's say, disconnected circuit, inductors are piece of wire, and the voltage source is short as well, so it is like a piece of wire. So what did I measure? Basically, I measured this potentiometer, which was fully rolled on, full volume. So I measured this value in some tolerance, and depending on how the multimeter actually works in measurement of impedance, I may slightly measure some currents in this spot, so the value from 500k was lowered probably because of this, or maybe there is some very high resistance in the breakup somewhere in the middle. Now, this is the DC resistance. What I saw in the REW was slightly lower. It was something like 300k. Why is that? Well, I don't know if the REW counts with the impedance of our audio device, which is not designed as a measurement device, it is audio device. So basically the maximum value may be affected by this impedance here, because if we calculate with this one in parallel with this one, we can get something like 350k or something like that in the DC. And as we go, let's say, from almost zero frequency higher, the value dropped, let's say, 2.5. What we measured, let's say, on 300 Hertz? We measured this impedance in parallel with this impedance, and there may be some currents flowing through this capacitor. Most importantly, some currents was flowing through the tone stack circuit, because on the, let's say, 300 Hertz frequency, this capacitor has an reactance something like 10k or 11k. So you can imagine that the amount of current flowing through this spot, 500 and something kilo ohm resistance. So it means that these two are actually equal. And as you know from combining impedances of cabinets, if you get some impedance in parallel, these are actually half if they are equal. So this is the reason why we dropped with the impedance right here. But what's going on next? We got this dip, which is very thin, and this dip is caused by a resonance. And in this case, because it is like V-shaped, this is a series resonance. And series resonance circuits has always the impedance like a V-shape. So at the resonant frequency, there is the most current and the less impedance. So it actually means that our broken pickup needs to have here not the disconnected circuit, but some capacity. How is this possible? Well, let's imagine that the pickup has been, let's say, in some very cold environment, or the tension while producing was uneven. And let's say we broke something right in the middle. So you can say that the wire is disconnected. Yeah, that's true. But if you imagine, let's say we have the inner inductor and the outer half inductor, they are still close next to each other. And again, they have some common surface, and they are in some distance. So again, we are talking about the capacitor. So, of course, the frequency characteristics will be affected by this, but it will work. And this is the reason why we have this dip and why it is so sharp. Because the measurement is kind of high impedance. These two are in series. This is like a short circuit, and this 15K, let's say, does not affect the resonance itself, because there is almost no current, because the measurement circuit is high impedance. We got, let's say, more than 10 times of this resistance. So the Q of this resonance is quite high, and the resonance is quite thin. It continues next to, let's say, the common behavior when this capacitor is in charge, and basically it is like RL circuit, 12 decibels per octave, and this resonance is wider because there is the resistor actually between these two components, and there is almost like maximum current flowing through, and the current is damped, and the energy is changed to the heat right on this resistance. So the resonance is actually wider. From this point to the higher frequencies, the pickup behaves as the others, so there is nothing more important to talk about. What did we learn? Broken pickup if it is broken somewhere in between the actual turns, it may still work. So now we know that the white guitar has a broken pickup, and it makes this one kind of disqualified from this test. But it still doesn't explain why the red one is the most bassiest one in my collection. So what I'm gonna do now, I want to test if the problem is in the hardware or in the actual piece of wood from which the guitar is made. So what I can do, I can change the hardware. So I will change the locking nut, and then I will change the Floyd Rose. And I'll take these parts from the white guitar because I don't need this one for this test anymore. And I'm very curious if there will be some change in tone, because I tried to check the weight of the Floyd Rose system and the locking nut, and they seems to be exactly the same. So let's hear some audio samples. That's interesting. And now, what if we compare the blue one with the red one modified? So, what's the conclusion here? Well, this guitar definitely needs a new pickup because it is kinda 3-4 decibels quieter and there is almost no low end, which is not a problem, but in comparison to the other guitars, it kinda is. So, this pickup is broken anyway, so new JB TB4 and everything should be fine. Now, in case of this guitar, it's a little bit more complicated. First of all, the locking nut, original black, is bad because after I changed it from the white one, there is almost no sitar buzzing at all. So it seems that the black one was made improperly and with bad tolerance. So I definitely need to buy one of these. And the bridge itself, after I changed it from the white guitar, there is less boomy low end and there is like more high-end precision present, especially when I play some chaga stuff. It doesn't mean that the guitar sounded bad, because for example in this video you can hear that the sound is absolutely okay. I can say it's kind of kick-ass, but now I know that the sound can be better, first of all, and secondly it can be more similar to the other guitars I have. So probably I will leave this tremolo right here and I will try to solve what is the issue with the black one, because this one is actually black chrome. I don't know if you can see, but yeah, this color is dark as well, but yeah, you know, in this case I just probably leave this one here because it just works. Now I want you, ladies and gentlemen, to tell me what is your opinion on this. Can you hear any audible difference at all? Or do you have some question to this test? Or do you have some similar experience with the guitars? You know what, just leave a comment below, and if you like this video, hit the like button, hit the subscribe, ring the bell, do the YouTube stuff, and you will be notified when I release my next video, which will be about the cables and how they affect the sound from various sources like guitar pickups, microphones, or some line sources. But that's all for today, ladies and gentlemen. Thanks for watching until the end, and I see you next time. definitely need some locking nut, and in case after I changed it to the, but definitely I need some tube screen. So this is this the hardware of this guitar is kind of já se na to vyser.